Alright, you're welcome to my YouTube channel. Remember, I'm still the boiling point. Please, if you've not subscribed to my YouTube videos, do well to subscribe. Today, I'm going to be entering into another topic in physics, which is work, energy, and power. So please, if you've not subscribed, if you've not watched my previous videos on units and measurements, which is chapter 1, we have scalar and vector quantity, which is chapter 2. Then we also have motions. So I was able to solve past questions on motion, the different types of motion, both the linear motion, vertical linear motion, horizontal linear motion, circular motion, projectile motion, simple harmonic motion. We are done solving past questions on these types of motions. So today we are going to be entering into another topic, which is work, energy, and power. But before I start solving past questions under work, energy, and power, I just want to take 5 minutes of your time to be able to explain the concept of work, energy, and power. The first thing I want you to note is this: work, energy, and power, all of them are scalar quantities. Work is a scalar quantity, energy is a scalar quantity, power is a scalar quantity. That means they have what we call magnitude, but they don't have direction. So they have magnitude, they don't have direction. That is note number 1. So in the concept of work done, what is work done in physics? If you hear the word work done, what does it mean? Work is said to be done whenever a force is applied on a body to cause the body to move through a distance in the direction of the force. I repeat, work is said to be done on a body whenever a force is applied on that body to cause the body to move through a distance in the direction of the force. What do I mean? If I have a body, let me say this is the body now, and I apply a force on this body, the force that I apply on this body will cause this body to move. Let me say this body was at point A, the body will now move from point A to point B. So when the body moves from point A to point B, you will discover that work is done. But there's an interesting thing I want you to note here. If I should ask you now, what is the direction of the force? You will discover that the direction of the force is towards the east because it's pointing this way. What is the direction of the motion of the body? The direction of the motion of the body is also towards the east. So what did you notice? Did you notice that the direction of the force, the direction of the motion of the body is the same thing? Are you getting me now? So if the direction of the force and the direction of the body, motion of the body is the same thing, then work is said to be done. Do you get it now? For example, if I apply this force and the body apply the force, let me say the direction of the force is towards the east. And instead of this body moving this way, the body started moving up. If the body starts moving up, my dear, work is not done. Why? Because the direction of the force and the direction of the motion of the body is not parallel, they are perpendicular. But I'm going to prove that while I'm trying to understand the concept of work done. So there are different types of work done. I want you to note this. There are different types of work done. Number 1, we have work done in horizontal plane. Work done in horizontal plane. So you need to understand the concept of work done in horizontal plane. Horizontal, remember, you still need to understand your coordinate system. Now we have the x-axis. This is the x-axis. We have the y-axis. So if the body is moving in x direction, that means the work that is done by that body in x direction is work done in horizontal plane. But if the body is moving in y direction, that means the work that is done by that body is called work done in vertical plane. So the formula for calculating work done in horizontal plane and the formula for calculating work done in vertical plane are not the same. Now, if the body is moving in horizontal, the body is moving in horizontal, you will discover that this body is not being affected by acceleration due to gravity. They are not affected. Why? Because it is not moving in vertical. So if they are not affected by acceleration due to gravity, what will be the formula? You have that the work done by that body in the horizontal plane will now be force times distance. And you know, according to the second law of Newton, force is equal to mass times acceleration. Therefore, I'll have it that mass times acceleration times distance is called work done in horizontal plane. So it is called MAD, where M is mass, A is acceleration, and D is distance or displacement. But in vertical plane, now listen, in vertical plane, what did you observe? You discover that the body is moving up and down. So if the body is moving up, you discover that the body is being affected by a gravity. If the body is affected by the gravity, that means I will consider acceleration due to gravity in the formula. So I will now have that the work done in vertical plane will now be mgh. If it is moving in vertical plane, it's mgh. If it's moving in horizontal plane, it's MAD. Where m here is mass, g is acceleration due to gravity, and h is the height in which the body moved through. So another thing I want you to understand is work done on an inclined plane. Work done on an inclined plane. So it is possible for work to be done on an inclined plane. Now, definitely, if you put an inclined plane, that means there is an angle. You get it now. So what is the formula for calculating the work done on an inclined plane? The work done on an inclined plane is force times distance, then cos theta. I don't want to start proving this, but this is the formula. Anytime you are solving a particular equation and they give you theta in work done, please, this is the formula you apply. The work done is equal to force times distance cos theta. Now, because of the presence of this theta is an angle. The angle can range from 0 to whatever, to 360 and all that. So depending on the angle that exists between the force and the distance, we have different types or classes of work. That means work can be positive, work can be negative, work can be zero, depending on the angle. For example, work is positive. Remember, I'm summarizing. Work is positive if theta is greater or equal to 0 and less than 90. If theta is equal to is greater than or equal to 0 or less than 90, then work is said to be positive. Now, but work is said to be negative. Work is said to be negative if this theta now that you're seeing is less than or greater than 90 degree, less than or equal to 180 degree. At this point, you discover that work done is said to be negative. Then work done is said to be 0. Please note this. They will still ask you question based on this. Work done is said to be 0, number 1, if theta here is equal to 90 degree. So anytime theta is equal to 90 degree, work done there is equal to 0. Another thing, when force is equal to 0, or when distance is equal to 0. Why? Because if you apply it in the formula, when it is 90, that means cos 90. What's cos 90? 0. 0 times everything here is 0. When the force is 0, force is 0. 0 times everything here is 0. When the distance is 0, distance you put it 0 here. 0 times everything here is what? 0. So the question is, when is work said to be 0? Work done is said to be 0 when the angle between the force and the displacement is equal to 90 degree, or when the force is equal to 0 degree, or when the body is at rest. When the body is at rest, that means the distance is equal to what? 0. So these are some of the things you need to understand in the concept of work done. Another thing I also want you to understand the concept of work done is that they can ask you, when is work done said to be maximum? If they ask you when is work done said to be maximum, work done is said to be maximum when the angle is equal to 0 degree. So what does it mean? If the angle is 0 degree, it means that both the direction of the force and the direction of the motion of the body is parallel to each other. Both of them are moving in the same direction. If both of them are moving in the same direction, work done on that body is said to be 0. Why? Because cos 0 is 1. 1 times force times distance will give me force times distance. Are you clear with that? Then another thing, when is work done said to be minimum? Work done is said to be minimum when the angle is equal to 180 degree. When the angle is equal to 180 degree, please note it. You get. So now we've been able to understand the concept of work done. Another thing I think you should be able to understand is the concept of energy. The concept of energy. So the concept of energy. Now, energy. We have different forms of energy. We have what we call mechanical energy, we have light energy, we have heat energy, we have chemical energy, we have a lot of forms of energy. Do you get now? But based on this topic, the predominant energy we want to study is mechanical energy. Mechanical energy. This mechanical energy is divided into two. One, we have kinetic energy. Two, we have potential energy. Please note this. Kinetic energy, we have potential energy. What is kinetic energy? Kinetic energy is the energy possessed by a body as a result of its motion. So whenever a body is in motion, the energy possessed by that body in motion is called kinetic energy. Are you getting what I'm saying? But if it is potential energy, the energy possessed by a body as a result of its rest. That means the body is not moving. If the body is not moving, this type of energy is called potential energy. So they can ask you a question: the energy possessed by a body by the virtue of its position, that means the body is not moving, it is called potential what? Energy. And the formula for calculating kinetic energy is equals to half mv squared, where m is mass and v is velocity. Now, this potential energy is largely divided into two. We have what we call gravitational potential energy. Please note this. We have gravitational potential energy. Then we also have elastic potential energy. Gravitational potential energy, the formula is mgh. The formula for calculating the work done in vertical plane. The same formula for calculating the gravitational potential energy. Why elastic potential energy? Where you talk about elasticity. So the formula for calculating the energy, that is elastic potential energy, is half fx, where f is force, x is a distance or extension. Then another one, you can also apply half, then you have it as k s squared, or half, you have it as f over x, sorry, f over k. So these, or f squared rather, over k. So these are different formats of applying elastic potential energy. So we are done with energy. The last concept of this topic is called power. The last concept of this topic is called power. What is power? The ability to do work. So therefore, if power is the ability to do work, the formula for power is work done over time. The rate at which work is done is called power. So rate has to do with time. So now you recall that what is work done? Force times distance over time. Abi? Force times displacement. So where F is force, D is displacement, and T is time. But if you can recall, displacement over time, what is displacement over time? Displacement over time is velocity. Therefore, power can also be force times velocity. So depending on the nature of the question. So now we've been able to summarize work, energy, and power. The first question on the board, which is what we want to enter now. So what is the first question on the board? Now listen. They said for a body moving in a circular path, the work done by centripetal force is dash. For a body moving in a circular path, the work done by the centripetal force is dash. A, negative. B, positive. C, constant. D, 0. Now listen, let's analyze this question. I have a body that is moving in a circular path. Remember that this is the center of the body. Now they said the work done by centripetal force. So we are talking about centripetal force now. What is centripetal force? Centripetal force is the force that actually keeps an object in a circular motion, and that centripetal force, the direction of that force is towards the center. So the direction of centripetal force, direction is towards the center. That means it is moving inwardly. Now if the direction of centripetal force is inwardly, what is the direction of the motion of the body? The direction of the motion of the body is tangential. Are you seeing it now? So the motion of the body is moving this way, the centripetal force is moving this way. Question: what is the angle between this body? It's called that the angle between this body is angle 90. So theta is equals to 90 degrees. So if I should apply the formula for work done by centripetal force, I will have it as force times distance cos 90. So the question is, what is cos 90? Cos 90 is equal to 0. So 0 times distance is 0 times force is 0. Therefore the work done by centripetal force is equal to 0. So the correct answer is option D. Option D is the correct answer in this. That is question number 1. So question number 2, they said a person is holding a bucket by applying a force of 10 Newton. So I just carry bucket and I'm holding it. If I carry bucket, that means I'm lifting it up. If I'm lifting it up, it is moving towards the vertical. Please note that holding a bucket by applying a force of 10 Newton, he moves a horizontal distance. He now moves a horizontal distance. So my force is upward and I'm moving horizontal distance. So please note, of 5 meters, and then climbs up in a vertical distance of 10 meters. So the question is, find the total work done. Find the total work done. Listen, for us to be able to analyze this, you discover that this man or that person is actually moving in 2 directions. He is moving in horizontal axis, also moving in vertical axis. So I will start with the horizontal axis, because at the end they say we should calculate the total work done. So the first movement or the first work done by the body is horizontal plane. In the horizontal plane, what did you observe? You discover that the force, they gave us the force, which is 10 Newton. Then they now said that this man actually moved in a horizontal distance. If the man is moving in a horizontal distance, what is the value of the distance? They say it's 5 meters. Now, the force and the direction of the man are perpendicular. If the force, because the force is moving up and the force is 10 Newton, right? The direction, which is horizontal, of the motion of the man is 5 meters. Did you discover that the force and the distance is perpendicular to each other? If it is perpendicular to each other, that means the angle sustained here is 90 degrees. If the angle sustained is 90 degrees, remember I'll apply that work done. The work done will now be force times distance cos 90. Cos 90 degrees. Cos 90 degrees is 0. That means the work done in horizontal plane is 0 Newton. Sorry, 0 joules. So this is just for horizontal. But for vertical plane, so they say the man covered a height. So if the man covered a height and they've given us a force, that means force, work done will now be force times the height. You get? So what is the height? That is the vertical distance covered by the man is 10. Why the force is 10? I will have it as 10 times 10. What is 10 times 10? 100. So I have it as 100 Newton. I'll have it as 100 Newton. Therefore, the total work done will now be the work done in the horizontal plane plus the work done in the vertical plane. What is the work done in the horizontal plane? 0 plus the work done in vertical plane, 100. So 0 plus 100 is 100 Newton. Please note that. So do we have 100 Newton in the option? Okay, option A, we have 50 joules. Sorry, 100 joules. That is the unit of work done. Do we have 100 in the option? Option A, they say it's 50 joule. No. Option B, 150 joule. No. Option C, 100 joule. Yes, I have 100 joules. So please, this thing is joules. The unit of work done is joules, not in Newton. So question number 3. Question number 3. Question number 3. Question number 3. They said the work done by gravitational force when an object of weight 50 kg on the floor moves through a distance of 3 meters is dash. Option A, 500 joules. Option B, 150 joule. Option C, 0 joule. Option D, 1500 joules. So how do you analyze this? You are calculating the work done by gravitational force, and the work done by gravitational force always moves in the vertical plane. So the gravitational force is moving in the vertical plane. So what is the gravitational force? That is the one we are trying to calculate. Then they said by a weight of 50 kg on the floor move through a distance of 3 meters. So that means this body is actually moving through the horizontal plane of 3 meters. Of course, remember this is 90 degrees. Why is it 90 degrees? You discover that the gravitational force and the distance moved by the body are perpendicular to each other. And I've taught you, if they're perpendicular to each other, that means the angle between them is 90. And if the angle between them is 90, that means the work done here is said to be 0 joules. The work done here is said to be 0 joules. Now there are some people that will want to solve this. Now they will say, okay, they gave us mass of 50 kg. They will now say 50 times it by 10 times it by 3. Definitely you still get the answer, but that is not the correct answer. Why? Because they want to test your knowledge whether you know that if the force and the displacement of the motion of the body is perpendicular to each other, what will be the work done? The work done will be equal to what? So you don't even need to solve if you actually know how to analyze the questions. So question number 4. A container with a mass of 5 kg is lifted to a height of 8 meters. How much work is done by the external force? How much work is done by the external force? So I have a container of mass. So the first thing I will do, I'll bring out my data. So what is the mass? The mass that I'm having here is 5 kg, right? I have a mass of 5 kg. It's lifted to a height. So they gave us height. What is the height? 8 meters. So how much work is done by the external force? So remember, if the man lifted it to a particular height, that means I'll have acceleration due to gravity, which is 10 meters per second square, right? So I will now have the work done by external force will now be mgh. So what is the mass here? It's 5. 10 times height, which is 8. Let's point our calculator. Let's point our calculator and be able to solve this. I'll have it as 5 times 10 times 8. I'm going to have it as 400 joules. I'll have it as 400 joules. So do we have anything like 400 joules in the option? Yes. Please, it cannot be minus 400 joules, because I did mean they said we should calculate by work done against gravity. If it is work done against gravity, it will be minus. But this question says work done by external force. If it is work done by external force, it will be positive. Please note. Then question number 5. Question number 5. They said the energy a body possessed by the virtue of its position is dash when they get angry and leave the hall. What is the option? Option A, potential energy. Option B, kinetic energy. Option C, work done. Option D, power. Therefore, the energy possessed by a body as a result of its motion is kinetic, but as a result of its position, underline the word position, is potential energy. So the correct answer is option A.